Hello, I'm Hongdan. I present structural inheritance controls Crustal scale extensional fault-related fault across the Dampier subbasin. So, what is extensional fault-related fault? This definitely is a type of very common structural in extensional basins, but it has not been really paid enough attention instead of the constructional counterpart, which has been developed very well in the last 40 to 30 years. The extensional fault-related fault actually consists of the fault bend fault, where they have a kink in the middle of the fault plane, district fault as well, fault propagation fault, and fault propagation fault with the presence of salt. The thrombose fault, where the fault displacement varies along strike, and as a static fault, well, normally observed in the low angle normal fault or detachment fault in extensional terrains. In outcrops, we see very commonly the development of high wall syncline in the Gulf of Suez. Well, it typically have a elongated axis perpendicular to the strike of the fault, and away from the fault, they bedding deep, shallow, but close to the fault, the bedding are quite steep. So if we go too close to the fault, we see that there's a deep fault. Close to the fault is a synthetically deepening synkinematic strata. Away from that, the strata flattens. So some marine examples has been phenomenally observed by Dane and McLean in 2019, which shows that Indobiterius has a major fault, and in the high wall of it is a series of an echelonly oriented high wall fault-related fault. The linkage between the fault actually is dominated by a lot of intensely fractured high wall. So, okay, so back to our talk today. This still zooming into the Northern Canal Basin, and this basin consists of 4 subbasins in the inner part of the passive margin. So we're going to show the gravity map of this area. We see that the Exmouth subbasin, Barrow subbasin, Dampier subbasin, the bigger subbasin were developed actually in the northwestern part of the Pilbara Craton and the Capricorn mega terrains. The western part of this subbasin is bounded by Rankin Platform and Alpha Arch. So basically, these subbasins were developed in the boundary between Pilbara Craton and the northwest shelf. Therefore, it's a weak zone, easy, susceptible for reactivation, which is also named as Western Australia shell zone in this boundary. So we firstly show a cross section through the Exmouth subbasin and then go to the Dampier subbasin to see the detailed structures of this type of extensional fault-related fault. The Exmouth subbasin, a deep part of it is a large Crustal scale or lithospherical scale fault, which has a displacement of up to 15 kilometers. They bounded the northwest shelf and the Capricorn terrains. On top of that is the formation of high wall syncline developed during the later Triassic and Jurassic. So this basin is developed actually in the high wall of a large Crustal scale extensional fault-related fault. So move to the north, the Dampier basin consists of the Indobiterius in the southeast margin, the Lewis Trough in the center, and Rankin Trend, also the Kendrick Trough and the Mandalay Trend to the north, in the northwest. We show 2 cross sections in the north and the southern part of the basin to show the internal structures. We see that the southeast part of the margin tilted in the northwest, and the central part is a depot center. we can see stratigraphic overlaps. Western part of the deformation is dominated by anticline, which have been faulted by crystal collapse graben. This is deformation. We see that there is a flat ramp geometry, and on top of that is a extensional fault-related fault faulted by the crystal collapse graben. In the eastern margin, we see that the boundary fault has been inverted during the later stage of this inversion. In the southern part of the section, we see the center part of the Lewis trough is dominated by symmetrical syncline, and the stratigraphic overlaps can be observed at both margins. The western part of it is actually the big anticline. It has been faulted by crystal collapse graben. Observation and interpretation shows that it's a flat ramp in the western margin. Therefore, let's cross the scale structural. If we zoom into the western part of the Rankin platform, we see detailed structures of the Rankin trained, Kindred trough, and the Mandalay trained. So we see that in the Cretaceous and Jurassic stages, the depth centers in the Kindred trough are in echelonally oriented. In the western, in the Mandalay trained is similar. It shows the echelon right lateral in echelon fold. The western part of the Rankin train is like host blocks of a triangular shape. So downwards to the only Jurassic and late Triassic, we see that the Rankin fault system is not linked, but rather segmented. They truncate the northeast trending faults and forming the triangular geometry, which serve as the reservoir for large gas and oil provinces in this particular area. So in the southern part of Rankin train, we see that Keystone graben can be tracked all the way from the Rankin train to Kindred trough. So they are actually continuous. They were separated by the Rankin fault system, which probably formed later. This is the 3D geometry of these fault systems within this particular part. We see that it's actually in echelon segmentation indicates the oblique extension. So based on all these observations, we create the block diagrams, which consists of the deep trough, which forms by echelon depth centers, which developed in the hanging wall of a large deep-seated basement fault that separates the Pilbara Craton and Ellsworth Shelf. So to the west of the deep trough is the echelonally oriented hanging wall anticline. And the fault truncated upwards is also like a northeast trending echelon segment. But this segment truncates the only developed northeast fault, which therefore forming the triangular or angular shaped geometry in the Rankin train, so as the gas and oil reservoir that discovered. So we use the numerical modeling to simulate this process. We see that the flotation of the spot block bonded by antithetic by pre-existing faults. When they propagate upwards, they will deform the hanging wall geometry, and this hanging wall geometry finally controls the geometry, the formation of the hanging wall syncline, which is not directly bounded by fault, but rather by have a symmetrical syncline geometry. This observation and the numerical modeling allow us to rebuild the evolution of Dampier-Rankin Basin. In the initial stage, after the late Paleozoic rifting, they have a thick layer of weak layer of deformation of local shell, which have a thickness of 400 to 2 kilometers. Reactivation of this basement boundary found between the Pilbara Craton and Ellsworth Shelf, forming a monocline because of the ductile deformation, folding deformation of the local shell. Continued deformation truncated upwards and breaking the local shell therefore forming the hanging wall anticline and syncline, and deactivated this footwall graben. So after this Mesozoic rifting stopped, the inversion caused by the mid-Miocene reactivation created inversion anticline in the margins. This is because of this weak zone between the noticeable shelf and pubic keratin are easy or susceptible for stress concentration. So this is my talk. Thank you very much.